thing that we are going to talk about is why would we use a DSLR camera instead of your phone? Because all of you have a phone, like, always with you, right? That phone's there, you take pictures with it, super convenient, which is really helpful. So why in the world would we take this bulky, big, expensive camera with us? There's several different reasons, and this issue is really actually pretty complex and lots of big debate with it. But here's some of your most basic reasons why we're going to use a DSLR camera. So the Canon T5, which is we have some of the T5s, we have some T6s, and some T3s. It's like your entry-level DSLR camera. So it's like the very basic model. It has 18 megapixels, whereas your iPhone the iPhone 11 only has 12 megapixels. So right off the bat, that DSLR camera has more megapixels available to it, which kind of ties into the next one there, is your camera sensor is larger than DSLR. So we can blow up images to be larger, we can get more clarity out of DSLR camera than we can a phone. Your phone often looks really good on a computer screen or TV, and that's because they actually have a pretty low resolution. I know it seems like they don't, but when it comes to comparing a computer screen, or actually even worse, your phone screen, to a printed picture, the phone screen has a lower res than what a print can get. So a lot of times when we look at something like, yeah, that looks really good, and that's really because the quality of the screen itself can't produce and show us all the details that it's lacking. But if you were going to print it, you would see a big difference between the print quality and the screen quality. So I think the first two here are pretty big ones. We're going to have a higher resolution image, more quality to it. Then going on, you get more control with a DSLR camera. So iPhones don't let you control your shutter speeds, ISO, and f-stops. You have to download an app, pay for an app that lets you kind of control some of it. Androids actually do have a manual camera setting where you can control all of those things. But even still, what they allow you to control is very limited compared to what a DSLR camera can control. So like your f-stop on your phone, you pretty much have one f-stop. You can't really control that. I know you don't know what an f-stop is yet. We'll talk about it. But cameras have like 15 different settings for f-stop. Your phone has one. Okay. The next one would be your battery life. How long does your phone battery last?
Mine probably lasts longer than anybody's.
That's because you have a dumb phone.
Like a day.
A day, right?
Gone like a week.
Maybe a little less than a day, depending on how much you're using it in class, right? A DSLR camera's battery will often last a couple days. And the other advantage of that is even while you're out shooting, if your DSLR battery dies, you can just take out the battery and put a new one in. Phone battery dies, you have to put in a battery pack, and then you have a battery pack and a cord. And we all know how well those stay plugged in when you're trying to like use your phone. Right? And it's just one more thing to carry. You could change lenses. This is a huge one. Because of the fact that a DSLR allows us to change lenses, we can accomplish many, many different styles of pictures. So we can have a wide angle lens, so something that we're getting almost 360 degrees view from, or we can get a telephoto lens where we're zooming into 600 millimeters, both of which are drastic difference in what you can see. So one of them we're going to be able to see a lot of stuff off to the side. The other one we're going to be able to see something really far away but have it look really close. Your phone can zoom in a little bit, like 2 times optical, which is like nothing. Okay. So being able to change lenses, we can really control what we want to capture and how we're going to get it. And the last one here is low light shooting. Your phones are terrible at shooting when it's really dark out. You guys have all experienced that. You've taken that selfie and it's just not quite bright enough and you're like, "Ew, that looks gross." So you turn on the flash and then it looks even worse. DSLR cameras, we can shoot, I've taken pictures at 1 o'clock in the morning with zero light, no flash, just using the light from the stars and been able to get really cool photos. So we have more capability to take pictures at different light scenarios than we can with a phone. So there's your basic ideas. However, when it comes to knowing what camera is best, the best camera is always going to be the camera that you have with you. Right? It doesn't matter if you have an amazing DSLR camera and it sits on the shelf at home. If you never take it out with you, are you ever going to get good pictures with it? No. Right? So all these things that we're learning, we're going to be able to apply into your phone so you can get pictures. If that's all you have, that's all you have, and it's still going to be better than nothing. Okay? However, this DSLR camera will provide better quality images and allow you more control than anything else. All right. So let's look at how the camera works itself. So this would be a DSLR camera. We have the little like pink line with arrows on it. That's light. Cameras have to have light to work. Without light, any camera will not work. If we look at photography, it's Latin word, so breaking it back down into its Latin roots. Does anyone know Latin by chance? That's expected. So photography in Latin means light writing. So photo meaning light, graphy meaning writing. So it's writing with light. Without light, we don't get an image. So you have to have light, and that's one thing we're really going to learn this trimester is how can we control that light to get the image to appear how we want it. Okay. So in our cameras, light is going to come through this lens. This is our lens. It's going to hit this mirror right here. It's going to bounce up here to this pentaprism and come out the eyepiece where we look. Then when we go to take a picture, the mirror is going to flip up. We see in this image here, it flips up. Light comes through, then there's this like thicker purple line, number 6. It opens, which is the shutter, allowing the light to get to the camera sensor, or what used to be film back in the day. Okay, so all of that's going to happen as soon as you push that camera or the shutter release button, or some of you like to call it the picture taking button. Don't call it that anymore. Shutter release, or shutter button. Okay, this happens very, very quickly, and we're going to watch a video of that example. That's basically what happens. So the kind of cool thing with DSLR cameras is we see exactly what the camera is going to see. It's just bouncing light around. All right, so we're going to talk about the shutter, the aperture, mirror. The mirror, actually, we just kind of talked about. Sensor, ISO, and white balance. I'm going to move on, don't worry. I'm going to list these again. Don't panic when you didn't write them all down. So we're going to start with the aperture. Your aperture does 2 things. It's going to first control how much light comes into the camera. And then secondly, it's going to control your depth of field. So how much light comes into the camera and depth of field. Your f-stop, or your aperture, is stored in the camera lens. So depending on what lens you have, you will be able to reach different apertures. So like Yearbook has a really big 500 millimeter lens, so it zooms in. You've probably seen it at football games, it's huge. It can only get to an f-stop of 5.6 is its lowest it can get, where some of our other lenses can get down to 1.4. Okay, and it's going to make more sense a little bit, but just know that's another advantage of the DSLRs is by changing lenses, we can also get different apertures. Okay, so your aperture is referred to as f-stops. And what it's doing is it's measuring the opening of that aperture. How big is that opening? So you will see things for like f2.8, f4, f5.6, f8, f11, f16, and f22. Yes, those will be really important for you to write down and know. So those different f-stops are going to allow different amounts of light into the camera. So each f-stop, we call it one stop of light, is either doubling or halving the amount of light. So if we move from f2.8 to f4, we would have half as much light into the camera. And then from 4 to 5.6 would be half as much light again. Going the opposite way, so like 11 to 8, you're doubling the amount of light. So the two things the f-stop controls is what?
Light.
What about light? How much light and depth of field. Yes.
Wait, so if you move like from a high number to a lower number, it gets more light or less light?
Yeah. It's going to get confusing here in a real quick second. So moving from a low number to a high number is half as much light. What's confusing here is that's actually not a low number. That is a high number. It's a large opening. Okay? If we go on, the top pictures here show us how big that opening is. So you can see at a 2.8, our aperture, what is inside the lens, has a large opening, right? So a lot of light is coming in. As we get to other numbers, so we move to the 4.8, it closes off that opening as smaller, so we get half as much light. What's confusing is that does look like a larger number, so you would think more. It's not just a number, it's a fraction, right? F over 4, if you replace that F with a 1 over 2.8 or 1 over 4, which one of those is a larger number?
1 over 2.8.
1 over 2.8, right? So just try to think about it as a fraction, and it makes it a little simpler. The hard thing though is in your camera, you're like never going to see the F or the slash. You're just going to see 2.8, 4, 5.6. So you have to remember, the number goes up, it's actually a smaller opening. Okay? Here's where it gets even more confusing. A large aperture is referred to as the opening. So a large aperture means we have a big opening on our aperture. That also means we have a shallow depth of field. Yep. Okay, so large opening, a lot of light comes in, but we have a small area of focus. So shallow depth of field just means we have less area in our picture that's going to be in focus. A deep depth of field means we have a large area in focus. So a large aperture means a lot of light comes into the camera, but we have a small area of focus. And this is what's going to get confusing for like half the trimester. You're going to switch those up all the time. You're going to say small aperture, thinking 2.8 because it looks like a small number, but a small aperture would be the opening of the hole itself. It's like a 22. Okay. Of all of the ways to record this information, this is probably like one of the worst ways we could come up with recording camera data. But then at the same time, all of the other ways they came up with to record light and how to measure it, this is the best way. So, yes, it is kind of confusing, but just the more you use the proper terms with it and you actually study it, the more it makes sense. Okay, so large aperture means what for our depth of field? Shallow depth of field. Okay. So here's kind of an example of what that's going to look like. So if we had a 2.8, we're taking our picture, we'd have this dog in front of the little girl and a butterfly, which like, are you ever going to see a scene like this? Let's be realistic, come on. But this blue area is marking what's in focus. So we have a small area of focus, our depth of field is small, compared to if we had an f16. You can see you get more stuff in focus. Now what's kind of confusing with this image though, is it looks like it just kind of is a hard line. It's not really a line, it's more of a gradual fade. So it's not like if you're standing just on the inside of this line, you're gonna need focus, and then you take one step and now you're out of focus completely. It's a gradual transition. So it's going, at this point, it's going to start getting more and more in focus until our focus point. And after that, it's gonna get less and less in focus until it's completely blurry. Okay? Alright, so we're not really gonna do this as a table, we'll just do it as a class. When do you think you would want to have a shallow depth of field? If you're taking pictures, why would you ever want to have less stuff in focus? Yeah.
For like single shot portraits.
So portrait photography, right? We want people to look at the person, nothing else. So if we just make the person in focus, it's more obvious that's what we should look at, okay? When would you want a deep depth of field? Yeah.
Landscape.
Okay, landscape. Why would I want a landscape to be deep depth of field?
So,
Yeah.
okay, so it's like, so it's not, so you can see the entire picture. It's not, you're focusing on like one mountain.
Yeah, so you get a feel of the whole scene, right? How are you going to be able to tell what kind of aperture was used in the photo? You guys think so? Yeah.
By how much it's focusing on.
Yeah, how deep the depth of field is. So if there's a lot of stuff in focus, we know what?
It was small.
It had a smaller f-stop, right? Okay, is a 2.8 a large or small f-stop?
Large.
Large, right? So it's letting a lot of light in, there's a big opening. Is that gonna have a shallow or deep depth of field? Shallow. Shallow. Okay, so here's where we start feeling really comfortable, like, yeah, I totally got this f-stop thing. Just wait. Okay, is this a shallow or deep depth of field?
Shallow.
Okay, why do we know it's shallow?
Only drops in focus.
Okay, and it's not really just the background, it's how much is in focus. So here's where a lot of people end up getting confused with this. A shallow depth of field doesn't mean background's blurry. Because if we go back to like this image, we focused on this girl, I could have chosen to focus on the tree, right? So that background could have been in focus, but everything else would have been blurry. It's how much space or distance is in focus. So if we look at this photo, the tip of the nose is blurry, and then it travels down, the closer it gets to the eyes, the more in focus it gets, and then the further away it gets, the less in focus it becomes. So a really small area that stays in focus, okay? All right, is this a large or a small f-stop?
Large.
Large f-stop, there's less people confident with that.
I think it's large as well.
It's large.
Okay, why is it large?
Because it's shallow.
Because it's a shallow depth of field. We have a very small area in focus, right? This was actually taking on the railing right side of the classroom here. It's like this big, well, a couple inches tall. So you can see it's a little blurry, it gets in focus, and then everything else is completely blurry. Very small area in focus. Okay, a large or small f-stop?
Large.
Large f-stop?
Yes.
Why?
Smaller depth of field.
Yeah, we have a shallow depth of field. All right, less area in focus.
Oh,
Small f-stop.
Small f-stop or aperture, because why?
Larger depth of field.
Because we have a really large depth of field, right? It's really deep, is what we would call it, a deep depth of field. So we have a lot of stuff in focus. How far away is this ground compared to those mountains?
Far.
Miles, right? And they're all still in focus. Ooh.
Yeah, mostly small.
So every picture we're getting less and less confident, even though nothing really changed.
Well, it's because you're like, ooh. But I'm pretty sure it's small.
It's focused on one.
Shallow depth of field or deep depth of field? Deep depth of field, which would mean small f-stop. Okay. But now when you look at this photo,
It looks photoshopped.
it looks photoshopped. How fantastic does this photo look? Sadly though, this is better than like half of you turned in for the pretest, so. Well, that's okay. All right, so not necessarily fantastic, it looks Photoshop. Where do you look at in this photo?
The towers in the back.
The pattern.
The pattern? Is that what you said?
The towers.
The towers? Okay, so we kind of look at her, right? And then we like quickly want to not look at her. But she has color on. Shouldn't we want to look at color?
It doesn't help.
If we don't use color properly, do we pay attention to it?
No.
We have to pay attention to color, right? Okay, so when we look at the towers, how many of you look at like the cars over here too?
Yeah.
You just kind of start looking absolutely everywhere in the photo?
Yeah.
Yeah. So here's a lesson for us. First, this is our lesson on why aperture is important. As the photographer, what are you telling us to look at?
Like in this picture?
Yeah.
Oh, the person trying to.
You're trying to tell us to look at the person, but like, you kind of failed, right? So why? Why don't we keep looking at her?
There's too much in focus.
There's too much in focus, right? There's too much for us to see. If it's in focus, we're gonna look at it. So we look at her, but then we start looking everywhere else. Ooh, what's this over here? Oh, what's that? Oh, let me see over here, right? She's placed almost on the third line, right?
But she's looking to the outside of the photo.
Uh-huh. She's looking back. What would have happened if they would have actually just put her on a third?
People would have probably looked at her.
We would have looked at her, and she wouldn't have to look off the frame, right? She's looking back because the camera's almost behind her, right? If she would have just moved, she could have looked straight at the camera, right? But here's the main reason depth of field is important. All we would have had to do is know how to use our camera and get a shallow depth of field. So this is someone that doesn't know how to use a camera. They probably bought a nice DSLR camera and went, I have a really nice camera, I'll get some good pictures now. And then they set it to auto. Once you set it to auto, you might as well just use your phone. Right? The camera doesn't know anything, it's dumb. You have to tell it what to do. So if this person just would have known what they were doing, they could have changed their f-stop to what? What would they have needed to do?
Make it large.
Make it a larger f-stop, right? So we get a shallower depth of field.
It's confusing.
And here's where we get into the Photoshop issue. It looks really fake, right?
Yeah.
Why does it look fake?
The lighting. Yeah, the lighting on her shirt.
Yeah, like, we have light hitting her shirt, but where's the sun in this picture? Back here, right?
Yeah.
Behind her? So if the sun's behind her, how is it hitting the front of her? Do we have two suns?
Tatooine.
Yes.
Yeah.
No, a flash. Flash photography can be done appropriately. More times than not, it's done terribly, especially if you're using your cameras on board flash. It will flatten your image, meaning it looks less three-dimensional, and it will often make it look fake. So it looks fake, so it looks like we took this picture of someone and then went and found a different background and just stuck them in there. Well, if they were taken at the same time, they would have the same kind of lighting. So the flash happened though because it was too dark. So their flash fired because the image was dark, but if they would have changed their f-stop to be larger to get a shallow depth of field, what would have also happened with light? more light, it wouldn't have been as dark. And then we wouldn't have needed the flash, okay? In this class, we are not going to use our flash at all. Flash photography is really tricky. It can do some really cool things, but you guys are honestly going to struggle enough just figuring out how to use your camera that trying to get you to use a flash properly is a terrible idea. So, flashes will never be used. The only way your flash will actually turn on is if you turn it on. If you use a flash, you will fail the assignment. Okay? Alright, so the next one we're going to talk about is your shutter. Your shutter is also going to control two things. It's going to control how long light comes into the camera, and it's going to control motion. So your shutter is stored in the camera itself. Remember, it's that little purple line right before the camera sensor. It's not really purple, it's black. But it controls those two things. How long light enters the camera and motion. So what did the aperture control again? What were the two things?
Light and depth of field.
How much light, not just light, but how much light comes into the camera and depth of field, right? So both of these two things are going to control light, but they're going to control it in a different way. So aperture is how much light comes in, shutter speed is how long the light comes in. Okay? How long light comes in, and motion. So if we have this example here, we're going to see these fractions again. These are actual fractions though, so these numbers actually make a little bit more sense. And they are seconds. So this first one here at the top left is 1/2000th of a second. So super fast. And then the more it goes to the right, it slows down all the way to like 1/3 of a second. You can see what happens as we start slowing down our shutter speed, we start seeing more and more motion.
Do we need to write those fractions?
I would. In your camera, you will often not see them as a fraction. You will see 2,000, 1,000, 500, 250, 125, 60, 30, 15, 8, 3, and then it keeps going down from there, which we'll see a little later. But those will go all the way to full seconds, 1, 2, 4, 6, all the way to 30 seconds. And just like the f-stop, the amount of light, or, yeah.
So like with football games or like sports games, do you use the less second?
Yeah, so the more we need to stop motion, the faster our shutter speed would be. And we're going to talk about some of those issues here in a second. But just like f-stop, we're going to half or double the amount of light or the time. So from 1,000 to 500 is half as much time for light to enter the camera. If we want to stop motion, we have a fast shutter speed. If we want to show motion, we have a slow shutter speed. So here's a, I guess, more complete list of those shutter speeds. You can see we can keep going into full seconds. There's even one after 30 seconds. It's called bulb, and it means the shutter will stay open as long as you're holding down the shutter release button. So you could take a picture for an hour if you want, just by holding down that button. Yeah.
When would you use that?
That mostly happens with like star trails and night photography. Okay, so what gets confusing though is we don't always see the fraction. So we have 8 seconds over here, but we also have an 1/8 of a second. Well, what you won't see is the fractions. So you'll see 8 seconds and 8 seconds. How do you know which one is 1/8 of a second, which one's 8 seconds?
Surrounding.
It actually has a parenthesis, or not a parenthesis, a quotation. If there's a little quotation after the number, it's full seconds. So if it just says 8, it's an 8. If it's 8 and a quotation, it's 8 seconds. There's a lot of numbers here. I'm going to tell you right now, it will be more beneficial for you as a photographer to learn all of these shutter speeds and f-stops. The other thing you'll hear is photographers will talk about what they're shooting at. So they'll say, I'm set at 500, 2.8, and 300. So those would be your shutter speed, f-stop, and ISO, which we're going to talk about next. They very rarely will say, I'm at 2,000th of a second. So they'll say 2,000 because we're lazy. All right, so we're actually gonna watch this little video clip. This is a camera. So what we're seeing is the DSLR camera, just the lens off. This piece right in the center is the mirror. What you're gonna see is the shutter speed is set to 200th of a second. That mirror's gonna pop up. You're gonna see the shutter open and close, and the mirror drop back down. And then this video is going to slow it down so you can actually see what happens, because as you're going to notice, 200th of a second is really quick, and you're going to miss it. And it's over. So now we've slowed it down, that mirror pops up, and the shutter is going to open and close. That green thing you see is the camera sensor. So all of that happens instantly when you press that shutter release button. So here we're going to see the shutter open and close again, and the mirror drops back down. Even slower, right there, that green bar, that's the camera sensor. So what you'll notice is this shutter will always open top to bottom. This is not the case, this wasn't the case, I guess, when cameras first came out. That shutter used to open in the center and get wider. Can anyone think of an issue of your shutter opening in the center and getting wider as time goes on and then closing back down?
Your center would have more light.
Yeah, your center would have more light, right? If it starts opening up in the center, light's already coming through before the outsides get any light, which meant the center was always a different exposure than the rest of your picture. So they moved to this top bottom thing, and it'll expose the top of your picture, going down, and then expose the next section, and then it kind of merges those all up together. It's just like a scanner, or a copy machine. It's the same concept. All right. When do you think you would want to stop motion? Why is that a thing? Yeah.
Like sports.
Okay, sports, when we want to see our subject, right? Okay. When wouldn't I want to stop motion?
I've seen pictures of like a waterfall, like people will set up like a really slow one so that they can see more motion in the waterfall.
Okay, so if we want to see that motion, water is an excellent time that a lot of times we'll see that motion. Other times, if we just want something to seem as if it's moving faster, we'll let some of that motion show. Like, you guys have all seen The Flash or old cartoons. When something's moving really fast, you can see like the streaky lines from them running. It makes it seem like they're moving quicker. Okay. All right, so looking at this example here, the pinwheel on the left, is that a fast or a slow shutter speed?
Fast.
Okay, what about the one in the middle? Medium,
Slow.
and then slow at the end. Could this one be a slow shutter speed?
Yeah, it wasn't moving.
If it was, how do we know that it's actually moving? We don't, right? So here's kind of the drawback. If we're stopping motion so we can see something, we also don't know that it actually was in motion. That pinwheel very easily could have just been sitting there. And it could have been the same exact shutter speed as this one, but there's just no motion. So when and how we use those shutter speeds, we kind of want to look at and say, okay, well, if I have a fast shutter speed, are they going to tell that there's any action in this photo? Well, maybe there isn't any action, then it doesn't matter, and it's fine. But if there is some action and we want people to know that there's action, maybe a fast shutter speed isn't going to be the best option for us. All right, when you look at this photo here, it should kind of give you that example of what happens as we slow down our shutter speed. So for this object here at 100th of a second, you can see it's mostly stopped. You can see a little bit of motion in his hands, but as we slow down that shutter speed, we get more and more motion with his hands and feet. So here's the next side of it. How fast that shutter speed has to be to stop motion is also dependent on the object in motion, how fast that object is. Okay. The other side of it is how slow can your shutter speed be and still get an image that's in focus. So what I mean here is the slower the shutter speed, the more it captures motion. All of us move, right? We breathe, which causes things to move. That motion can be picked up by the camera. How many of you have ever shot a rifle before with a scope on it? Okay. Have you ever zoomed that scope in to its magnification? Anyone? What happens when you zoom that scope in?
It starts moving when every little move you make is like.
Yeah, it's exaggerated, right? Like before, yeah, I can hold this pretty steady, it's right on target, and then you zoom in and all of a sudden you're like 10 inches off, right? It's moving all over the place. The truth is you're moving that much. You just don't see it when it's zoomed out. When it comes to our camera though, it sees that motion always. But zooming in will magnify it. So we can only hand hold a camera with a shutter speed of 60th of a second or faster. If it's slower than a 60th of a second, we're gonna see some motion. Just like that little teeny motion right there, something like that can come just from you breathing. And no holding your breath doesn't work to stop that motion because you're still moving. Your body will move, even if it's just a slight amount, the camera will catch up on that. Okay, so what's the slowest you can handle the camera? 60th of a second. Here's the other range for you though. That number actually changes depending on what lens you have. So the 60th is the slowest you can go unless you have a lens that is zoomed in more. So like that lens I was telling you that your book has, that's 500 millimeters. We cannot hand hold that camera at a shutter speed less than 500. So the shutter speed you can have to hand hold also is determined off of the focal length of your lens, or how much that lens is zoomed in. So if it's zoomed in to 200, your shutter speed has to be at least 200, or else it will show motion. But either way, even if you have like a lens like your guys' cameras that are 18 to 55, even if you're at 18, you can't go slower than a 60th. Okay. So here's an example of what those shutter speeds can do. Same exact scene. All we really did was change our shutter speed. Right, so a faster shutter speed is going to stop that motion. A slower shutter speed is going to allow the motion to be seen. Is there a different feeling or mood to both of these pictures? What's kind of that feeling or expression you would get looking at the photo on the left? Is it calm and relaxing?
Yeah.
Or is it a little bit more exciting? A little bit more exciting, right? It's still pretty, we still want to go to a beach, right? But then compared to a slow shutter speed where that water is moving, this just has a little bit more of that calming feel to it, right? So the shutter speed we have can also help control the feelings and emotions that people have when they look at our picture. All right, so when you look at this photo, is this a fast or a slow shutter speed? Fast, why?
It's not in the motion. You can't really see the water falling.
Yeah, because the water balloon is frozen, right? So it's a water balloon being popped, but it's frozen in time. So before gravity can even take effect and pull that water out of the shape, we've taken the picture and it's frozen that motion. Okay, what about this one?
That's slow.
Slow shutter speed. So this was taken by a student here. So he just had someone stand there and then he actually took a flashlight and went and drew all of these lines in while the camera was taking a picture. So we were talking several seconds here to get that to show up. Yeah,
So why doesn't it show like him with the phone?
because the light is not touching it. And so light's crucial. If light doesn't touch something, we can't see it. That's why even the background, we can't see because there's not enough light hitting the background. Which is also why you kind of see this glow here. He actually had to take the flashlight and like shine it down on his feet, or else his feet just blended into blackness. So he had to light him up everywhere. So this whole body, he had light, a flashlight shining on him, and he came in with another light and drew those lines.
Whoa.
Fireworks.
Fast,
Slow.
this is a slow shutter speed. It's actually not fireworks either.
It's Doctor Strange's little portal thing.
Yeah. Brandon Meekum, Mrs. Meekum's son, is Doctor Strange, actually. Yeah. No, so he took a rope and steel wool, tied the rope to the steel wool, lit the steel wool on fire, and it doesn't really burn, it sparks. And so he's just spinning it around and around and around. And since we have a slow shutter speed, those little sparks are lit up and they would fly off. So we're seeing each one of those lines is one spark flying off of that steel wool. That's why we get more light in that circle, because that light's repeating, so it gets brighter and brighter in those areas. And where it's bouncing off the ground and hitting more repeatedly, we see more light. So it's a slow shutter speed. Fast or slow shutter speed?
Fast.
How do we know?
Stop the movement.
Because they're frozen in time, right? Now, do we know that these people are actually moving, or are they posed?
They're moving.
They're actually moved.
Yeah. So we can tell they're actually moving for a couple reasons. One, their expressions. Like, you just can't fake those facial expressions. This is the joy of sports photography.
The hair.
Yeah, and then two, the hair. To get the hair to stay like either of those, you would need like a whole jug of glue to hold it there. Right? Slow? You guys are getting less and less confident with your answers. So this is, actually I believe it's actually an apple with sugar pouring over it. So you can, if you look, you can notice, you can see each grain of sugar traveling that whole distance. It's blurred from motion.
The heck is that?
Oh,
Oh, okay, I see what it is now.
So this is a super slow shutter speed. It's just one person spinning in a circle. But since it's slow, that light's able to capture them and we can see each step of that spin.
I thought it was an X-ray of like a hand, like a weird messed up hand.
No, it's not. All right, what about this one?
Slow.
Slow. Okay, so here's where shutter speed is going to get important. Let's say you are a photographer that got hired to take a picture for a whitewater rafting company. And this is the picture you took. It's beautiful, right? Mm-hmm. Are people going to want to go whitewater rafting with the company? Mm-hmm. Why?
Because it looks relaxing.
Yeah, it's too relaxing. When people go water rafting, do they want a relaxing float trip, or do they want to think they're gonna die? Right? They want to have to go, oh my gosh, if we go there, we might die. That looks like a lot of fun. Is that what this picture's telling us?
No.
Not at all. This is like, ooh, look how pretty that will be. That seems fun. We can have a little picnic on the raft. Okay? All they would have had to do is change their shutter speed to be what? Faster. If they had a faster shutter speed, that would then allow the water to not be blurred out together, like showing that nice calming movement. It would be splashing and kind of look like that picture on the beach. Water spraying up everywhere. It'd be a little bit more exciting, a little bit more scary. All right, so the next thing we're going to talk about is your ISO. Not iOS, ISO. This came first. This is also going to control two things. This is going to control how sensitive your camera sensor is to light, and it's going to control the image clarity, or how clear the image is. So a low sensitivity or a low ISO, or also what we refer to as a slow ISO, is going to be less sensitive to light, but produce a more cleaner image. A high ISO, or a fast ISO, is more sensitive to light, but will produce a dirtier image. A high ISO will produce something that we call noise. Noise often looks like pixelation, so little like pixels. It doesn't look very clear, and you often will get colored pixels into your image. So like little red or green dots will start showing up. So what's happening is there really isn't enough light, and you're telling the camera sensor to find more light, and what it ends up doing is kind of making up that information. It says, well, I think it should be this color here, so I'm just going to do that. Computers aren't very smart. I know they seem like it. They're only as smart as the person that programmed them. Okay, so ISOs, we also will start out doubling and halving light. So I have an ISO at 200. I can double how sensitive it is to light by going to 400. From 400, my next step would be actually 600. I know, tricky. Then from 600, you would go to 800, then 1600, 3200, 6400. And some of your cameras will go as low as 100. So 100, 200, 400, 600, 800, 1600, 3200, and 6400. Something we need to remember with these, though, is the higher our ISO goes, what happens to the clarity? It gets lower. Okay? So as we look at this image, this is something that often will happen if we don't have enough light and we just increase our ISO. It's pretty dark still, but how awesome is that photo?
It's like Five Nights at Freddy's.
Yeah.
Creepy.
It's kind of gross, right? First off, those are like original McDonald's toys. I know. McDonald's really has stepped up their game since I was a kid. But you guys just see how it looks like little dots or pixels all over the place? That's a lot of noise. High noise images are not worth it. It would be better to not take this picture than to take it with an improper ISO. Okay, here's your transition of how those ISOs will look. The TV is going to be better for you to see it as, but ISO 100, what you're going to look at is look at the shadows and the transitions between the lights and darks. And then as your ISO increases, can you see how you start getting more of that little noise? The clarity drops in those transitions. It just doesn't look that great. How high your ISO can go really depends on the camera you have. So some of our cameras are a little bit older, and their max ISO is going to be 800. So that would be like all of the Nikons we have, because they're super outdated. Those are all about, the highest you're going to want to get is 800. The Canon T6, we have some of those. You can shoot at 1600. Sometimes it'll be okay. It kind of depends on how many dark values there are. If it's at night, it's going to be really terrible. So in general for this class, we're going to max our ISO out at 800. Because anything above that for most of us is going to be too low of a quality. Now I said that depends on your camera. One of the cameras we have for yearbook, we got it to shoot at football games and basketball. Both of them are really dark. As you get your cameras and you go try to shoot in the gym, you're going to realize our gym is terrible. Even though it's new, it's really dark inside. So we have a camera that we can shoot at an ISO of 10,000 and not have any issues with ISO or noise. 10,000, right? Not 1,000, 10,000. So you guys are maxing out at 800. Your cameras, this is what 3,200 would look like. That other camera we can shoot at 10,000. I don't have enough of those for you guys because that camera itself is $6,000, right? So this is where you start seeing prices change in cameras, is typically what can they control? What kind of processor do they have? And image sensor. So a really expensive camera is going to be able to deal with higher ISOs, more so than what your entry-level cameras will cost. All right. So now that we kind of know what those three things do, we need to figure out how to use them together. All three of those are going to be used to take our pictures. It's time to get SD cards, huh? Shut up! Okay, so your camera is going to see the light. It doesn't see anything else. It doesn't see objects. It's going to look at light, and then it has this thing called a camera meter. This camera meter is going to measure everything from 0 to 10. And by measure, it's going to say, is it really dark or is it really bright? And then it's going to try to get on auto, it would be trying to get your settings to balance out to take a picture at what we call mid-gray or a 5. So in auto, and that's what your phones do as well, is it's going to look at that light and say, you know what, to get a good average picture, I need to have my shutter speed set to this, my ISO here, and my f-stop at this. Takes the picture at middle gray. What do we know about averages though? Are averages great? According to your parents, no, right? That's why they get mad at you if you have a C. Because averages are not the best. That's why we are never going to shoot in auto in this class. Everything we do will be done in manual because you are going to be able to make better decisions than what the camera itself will make. Okay? So it's going to measure the light like so. It'll have a 0 being the darks, 10 being the lights, and then mid-gray is where you're supposed to be, or at a 5. We get to make that decision for the camera though. We get to say, you know what, actually mid-gray isn't going to be correct. I need it to be a little brighter or a little darker. Okay? We get to make that choice, but to start out, we're first going to get our camera to take a picture at that middle gray. We're going to find the average, we're going to take the picture, and then we look at it and say, you know what, I think this needs lighter or darker. Okay? We just flipped to this picture. So this is an example of what you can accomplish when you actually know how to use your camera properly. So if we were to try to take this picture with auto settings, a couple things would have happened in the photo. First off, the background would have most likely been overexposed, and then her face would have been really dark. Because of where that light's coming in and how much of it, your camera would have realized that and been like, ooh, too much light. I need a faster shutter speed. And then our image would have turned out as beautiful. But when we, as a photographer, understand how to control our camera, we can recognize and say, you know what, if I have too fast of a shutter speed, her face is going to be too dark, I'm not going to be able to see it. So I'm going to change it off of middle gray to the proper exposure. Now proper exposure is it's kind of a tricky thing because there's no like formula for the proper exposure. It's really going to be you looking at the photo and saying, you know what, I feel like the light values are light enough or the dark values are where they should be. It's kind of a learned process, which is why we said that we're going to start out taking a picture at mid-gray, then we look at the back of the camera and we're going to make judgments off the picture and change it from there. Okay, so when we understand our camera, we can take good pictures. So this was taken by a student. I like to also point out when she first started, she was equally as bad as the rest of you. Like, you could go and ask her, she was really bad. But she took the time and learned and ended up being a really good photographer. Her whole senior year, she got paid by other students to do pictures for them. So if you try and do the things I tell you to, you'll be a good photographer. All right, so when you look through your camera, you're going to see something like this. This is what we call our camera meter. It's going to look slightly different based off if you have a Canon or a Nikon, but it's going to tell us a couple of things. First, we have our negative or our underexposed or blacks, our whites or overexposed. This big arrow in the center is our 0, or if we look at the mid-gray scale, it would be 5. So what's going to happen is when we tap our shutter button, we're going to see it light up. You're going to see an arrow or the number itself light up. It's going to tell you what your current settings are. And from there, you get to start making some decisions. So right now, when you look at this meter, what is it telling you is going to happen with your picture? So just based off what we see on the board, what can we already assume is going to happen if we take this picture? Yeah.
Will it be underexposed?
It would be underexposed, correct. How much underexposed?
3. 1.
One stop. Right? That's what the 1 is. Okay, so right now we know, okay, if I take the picture to get mid-gray, I would be 1 stop too dark. So what do you think I could do to make it not underexposed? Turn up my exposure a little? How? Okay, I could do something with the aperture. What could I do with the aperture? If it's too dark, yeah.
You could take it to the 2.8.
Okay, so get a larger aperture, 2.8. Why would that make it not dark? Exactly, you're letting more light into the camera. Okay, what's something else I could do if I didn't want to change my aperture? There's 2 other options. If my picture's too dark, I could change my aperture. What else could I change?
ISO.
Okay, your ISO. What would I do with my ISO?
Increase it.
Increase it. So what would the next ISO be? 400. Okay, what's the third option?
Exposure.
Exposure, also known as your shutter speed. What can I do with my shutter speed to make it not too dark?
Don't you decrease the speed?
Decrease the speed, so let light in for more time. Right? So I could change my shutter speed down to a 90th of a second, kept everything else would stay the same. That would move me to mid-gray. So that's what the camera says is the proper exposure. The camera's not going to be right most of the time though. So you'll take a picture here, look at it and say, ooh, does it look like I can see everything I'm supposed to see? Or does it seem a little dark? that's going to be a learning curve. There's going to be pretty much the whole trimester trying to figure out how to read that. And as time goes on, we're going to talk a little bit about that. But your first step is to get here. Get the camera to the mid-gray, look at it, and then make changes accordingly. Okay, now we have one exception to this always, and that's shooting in snow or the sand. What happens to light when there's snow all around? It reflects off the snow. So more light is going to be reflecting off of the snow towards the camera and entering the camera. What is your camera trying to achieve? What value? Black, white, or middle gray? What color is snow? White. What do you think will happen if you get it to mid-gray? It gets too dark and it looks gray. Do we want gray snow? No, gray snow looks ugly. So, if we are shooting in snow and our camera tells us mid-gray is, and we're at mid-gray and our camera is set to 1/25 of a second, f8, and 200, we're going to say, oh, you know what? I know the camera's going to make it too dark because it's snowy out. I'm going to need to overexpose my image by 1 or 2 stops. How am I going to do that? What can I do?
Make your shutter speed
Faster?
faster.
Slower. All right, because I want light to come in for more time. That'll make it brighter. All right, a faster shutter speed would make it darker. So if I'm already worried about it getting gray, I want to let it get a little bit brighter. So I could slow down my shutter speed by 1 or 2 stops, or what else could I do?
Get a larger aperture.
Larger aperture, or increase the ISO. Okay. So I could change my shutter speed to a 60th or a 30th of a second. If I did a 30th, what would I need? A tripod, right? Because if it's slower than a 60th of a second, you can't handhold it. Or I could change my f-stop to 5.6 or f4, or my ISO to 4 or 600. Or let's say I need a shutter speed a little quicker to stop any motion, but I don't really want to go below a 5.6 on my f-stop. I could do a 5.6 and change the ISO to 400. And that would give me 2 stops. Okay? So here's your example of what this looks like. Here's the photo taken with mid-gray. And here's what happens when you overexpose it by 1 or 2 stops. Can you see a difference in the values? Okay, on the picture on the left, can you see the people? Did you know there's people in it?
No.
Okay, look on the picture on the right. Where are the people at?
Picking up a bridge.
Right on the bridge. All we did was change the exposure, and all of a sudden we see more in our image. Right? The crop is exactly the same. We just have people actually showing up there because here our values have allowed to sink in. Yeah,
So how much of that can you change after you take the picture, like when you're editing?
we don't edit. Everything we do will be straight out of camera. A good photographer does not need Photoshop. In fact, if you can't take a good picture, there's no amount of Photoshop to make it good. Okay. So yeah, so all of this needs to be done in camera. All right. So the next one we're going to look at here is white balance. Now in your notes, I want you to make a clear shift, like separate your notes here, as white balance will do nothing to change the exposure of your picture. This will not change how light or dark your image is. White balance is strictly dealing with color. So white balance is going to tell the camera what white is actually supposed to look like. Our eyes do this really cool thing, or I guess it's our brain. Our brain automatically adjusts light sources to be white. So no matter what light source you look at, you're going to kind of switch it and make it look more white. So if you look at the back wall and you just keep staring at it, it's going to feel white. And then if you look over towards the door really quick, that light looks yellow. But the more you stare just at that light source and switch back, the wall then changes to a different color. Okay? Our brains are automatically trying to process this color change. Our cameras can't do that. They don't understand what light source we have. Each light source produces different colors. So like the sun, fluorescent light bulbs, tungsten candlelight, regular light bulbs, shade, all of those have different colors that are going to come out based off of how warm that light is. This is something that we've known for quite some time, and in film photography, we actually had different color film that we had to use based off of what kind of light we had. You guys are lucky to be in digital where you could just change that by a push of a button. With film, we had to take all of it with us. So if we were going to be shooting a wedding, we had to take rolls of film to use inside of the building, and we had to figure out first, was it going to be fluorescent light bulbs or tungsten light bulbs? Those were like the old round ones, because each of them gave different colors. Then we also had to take film if we were going to shoot outside, because the sunlight produced different colors. Then we had to have film in case we were shooting in the shade outside, because that was also a different color. This is why film photography was super expensive, because once you put in a roll of film, you had to finish it, and once you took it out, you couldn't reuse that roll of film. So you couldn't like shoot 5 pictures, switch film, and then switch back. You guys, every picture you take, you can switch your white balance. So, blessing for you. One of the things that really helped us understand this too, though, came from the invention of the fluorescent light bulb. So fluorescent light bulbs were invented, and they were like 10 times as bright as the standard light bulb. And people got really excited, especially females. Where's one place that you always want the most light? Why? When you're doing your makeup. You want to see yourself so you can actually apply it correctly, right? When you guys go buy makeup, how do you know what color of makeup to buy? Match your skin tone, right? So here's this really cool thing that happened. We put these fluorescent light bulbs in bathrooms because they were really bright. You could see really well. And then you started putting makeup on, and you're like, ooh, this looks good. And then you went outside, and people went, oof. Doesn't look good. And we figured out that fluorescent light bulbs actually produce green light, which is completely different than every other light source you would see. And so your makeup was a different color on your skin than you thought it was. Now our brains don't recognize that. We changed that light to be white. We have to tell our camera how to do that. So we have to recognize what light we have and tell the camera how to compensate for that. That's what your white balance is. Okay? So here would be our settings to white balance. We have presets, so we can just pick one of these, the camera will know how to change it, and we can move from there. There are 3 on this list that we will not use in this class. Okay, flash. Why won't we use flash? Because I told you can't use flash photography in here. Okay, what's the other 2? Auto, because auto sucks.
Tungsten?
No. Custom, because custom's honestly the best, but you're going to be too overwhelmed to know how to use it. So we're going to stick to the other presets because they're good. They're just not the best. But like, kind of like the Flash, there's some other things you have to learn first before you can really worry about doing the custom settings. And as you're going to see today, you're going to be overwhelmed just using the camera without custom. All right, so when we look at these white balances, you can see how they have drastically changed the appearance of the picture. So as shot is custom, so that's what the correct white balance is. Can you see how even the auto white balance is not quite the same color? Make sure to look at the TV, it's even more obvious. So auto, it tries to do a good job, but it just isn't that great. It's really not that close, so we aren't going to use it. So the rest of these, it's the same exact lighting, and they just changed each white balance so you can see how those colors affect or look under the wrong white balance. Here's a time where some of you are like, well, Mr. Feek, I really wanted the picture to be more yellow, so I chose the wrong white balance on purpose. That's a good try, but no. It's always better to have the correct white balance. Now, this is usually a problem because some of you are obsessed with filters on your Instagram. You should stop being obsessed with those filters. A hard thing with filters is right now they look good. Looking long-term processes, though, that's a fad. How many of you have ever looked at pictures of your parents when they were in high school and made fun of them for what they were wearing? Uh-huh. That's exactly what you're doing to all of your pictures when you put a filter on them. Is you're opening the door for your kids down the road to make fun of you. It doesn't seem like they will, but in just a short 2 or 3 years, those filters are going to be ugly, and you're going to be embarrassed that anyone sees them. So we're going to start by taking proper pictures first. From a proper picture, we can make changes to it to meet those fad requirements, but if you start with the fads, you can't ever go back to a good, clean, original picture. Okay? So we're always going to shoot with the proper white balance. Here would be another example of that. So if we had a tungsten light bulb on our model, but we changed it to daylight white balance, can you see how terrible that color looks on them?
It's like jaundice.
It's like I went to the dollar store and bought some tanning lotion because I live in Rigby and it's like 20 degrees for 5 months out of the year. And I'm depressed and don't want to look pasty white. Dollar store tanning lotion is never worth it, guys. Just be pasty white. It looks better than an Oompa Loompa. Don't do it. Some of you are going to struggle with this a lot. White balance can be really hard to understand and to see. Many of you will take a picture like that and be like, I don't see the problem with it. And then when you take the correct one, you're like, oh, I see a difference now. So one of the best tools, or I guess not tools, but tricks to do when you're having a hard time figuring out white balance is take the same exact picture with the different white balances, put them up on the computer screen and see which one has more evidence.